Okay, well, I'm continuing my study of AC motors, and I've built a motor here called a Synchronous motor, and a Synchronous AC motor, and it's just one of the ones that I stumbled on and wanted to build it up, and here it is. And I went ahead and worked more with that induction motor over there, and really wasn't all that happy with what I was seeing. Something wrong with the design, I'm not sure. But this one was very, very successful. And what I've done here is I've built up a neodymium magnet in front of a coil of wire that takes the 60 hertz signal and links up with that neodymium magnet and then drives Maggie as the load. And this is what I was not able to get hardly anything off. That was torque. And this one has the torque. So let me show you how it works. There's a 60 hertz signal on my system here at 12 volts. I've got a transformer I've converted to just an AC transformer by taking the guts out of it. I've got a kilowatt meter here. And any of you guys that work with AC know what this is. If you don't know what it is, get one. And this shows you what the power coming through that cord into your device is eating. And that thing right there, not even loaded, is eating 50 milliamps. About 12 watts of power. Here's the power on the watts. No, 2 watts. I'm sorry, 2 watts unloaded. And then it's pulling 50 milliamps at 2 watts. My signal here is 120 volts at 60 hertz. Now what I'm going to do here is first I'm going to show you how Maggie works. There's a neodymium magnet right there that spins up in front of her. I'll just take a battery here and turn this motor on, and you'll see her eyes light up as that magnet spins around in front of her. Little magnet's being spun up, and then that's causing her eyes to light up. And that's how she works. Now what I'm going to do is I'm going to turn this motor on with the battery with this system energized. And what I've got is a coil, just a straight coil with a 60 hertz signal being fed back and forth in that. So you got north, south, back and forth. And that rotor, when it gets synced up to that, keeps on turning. Now I'm using a starter motor here called a pony motor to get that up to speed, to get it to go. You can spin one up with your hands, but it's easier to just use a motor, and they call them pony motors, and this is the name of the motor. And you can look it up on Google. And I was very happy with this. They use these motors in clocks and turntables for microwave, the motor for that, and they run very consistently at the frequency you put into them. They're very constant, so they're a real good clock motor. Okay, let me turn this on. I'll show you what the a little switch here. Turn this on, show you what the amps are on this when I turn it on. Okay, there it goes up to 120 milliamps. And this is, you should be the 13 watts. Put it back on the amps. Okay, I've got the indicator light on. You can hear this humming. But you see, she's not doing anything with that at all. That doesn't excite her at all. The motor's not turning. And it doesn't turn unless you get it up to speed. So here's my starter motor. And that's all it took. Now the motor's running in sync with that 60 hertz signal. And old Maggie loves that. And that's just perfect for her. Look what it did. Almost nothing for the power consumption. And I thought that was very, very interesting. Anyway, that's my little latest AC motor that I've been working with, and I thought I'd share that with people, that this is an easy one to build up. Not hard at all. Thanks for watching.